Here we have a SAT math problem. Okay, let's go to the question. Here we have a figure. In the figure, about two circles have a common center O, and two rays from the center intersect the circles at points P, Q, R, and S. The measure of the angle POQ is 2 pi over 5, and the area of the shaded region of sector OPQ is 20 pi. If the ratio of OP and PR is 2 to 3, what is the length of the minor arc RS? Okay, here we have the central angle of the sector OPQ, that is the measure of angle POQ is given, that is given in radians, 2 pi over 5. Okay, the same central angle we have for the minor arc RS over here, that is here. Okay, and also we have the area of the shaded region OPQ, the sector, that is 20 pi, and we have the ratio between the lengths of OP over here and PR over here, that is 2 to 3. So now we have to find the length of this minor arc RS. Okay, now first let me write the formula to find the arc length. So arc length is equal to, so here we know the central angle of this arc RS in terms of radians. When the central angle of the arc is given in terms of radians, the formula to find arc length is r times theta. This theta represents the central angle in radians. Okay, so here to get the length of this minor arc RS, I need two quantities. One is the radius of the circle, radius of the bigger circle. So because we have this minor arc RS on the bigger circle, so we need the radius of the bigger circle. Either OR or OS represent the radius of the bigger circle. So we have to get the radius of the bigger circle and also the central angle of the minor arc RS. Already that is known, that is 2 pi over 5. So we can plug in this 2 pi over 5 for this theta, but we need the radius of the bigger circle. How do you have to get the radius of the bigger circle? For that we have to use other information. That is, we have the area of the shaded sector OPK, that is 20 pi. So using this information, I'll be able to get the radius of the smaller circle over here, that is given by either OP or OQ. Okay, for example, let me get the radius of the circle, the smaller circle OP. So once I get the length of this OP, I'll be able to get the length of this line segment PR using this ratio, because this ratio contains PR. So once I know the length of OP and PR, I can add them to get the radius of the bigger circle OR. Okay, now let's get the radius of the smaller circle, which is given by the line segment OP. So for that, I consider the area of the sector OPQ, which is 20 pi. Let me write over here, area of sector, let me write it, OPQ is equal to 20 pi. Okay, when the central angle of the sector is given in terms of radians, the formula to get area of a sector is 1 over 2 times r square times theta equals to 20 pi. So here this r is the radius of the circle. In this case, this r is the radius of the smaller circle, and theta is the central angle of the sector. Central angle of the sector is 2 pi over 5. Okay, 1 over 2 times r square times this theta is the central angle of the sector in radians. We can plug in 2 pi over 5. Okay, sometimes you'll be using some other formula to get area of a sector. That is for the central angle given in degree measure. But here the central angle is given in radians measure. In that case, this is a formula to find area of a sector. And here on the right side, we have 20 pi. Now we have to solve for r square. I mean, sorry, not for r square, for r in this equation. Okay, let me continue over here. So here this 2 will cancel out. Numerator, we have 1 times r square times 5. Then I'm getting pi r square over 5 equals to 20 pi. Let me multiply both sides by 5. When I multiply both sides by 5, I'm getting 100 pi. Let me divide both sides by pi. Then this pi will cancel. Here pi will cancel. R square equals to 100. Then I'm getting r equals to 10. Okay, now I got the radius of the smaller circle, that is OP equals to 10, either OP or OQ. Now let me consider the ratio of the two lengths of OP and PR, that is equal to 2 to 3. Let me write it over here. OP to PR equals to 2 to 3. Okay, now to get the lengths of this OP and PR from the terms of the ratio, I have to multiply both the terms of the ratio by the same non-zero number. That is, to get the length of OP, I have to multiply the first term of the ratio by some non-zero number, say x. Then I'm getting 2x as the length of OP. Now to get the length of the line segment PR, what I have to do is I have to multiply the second term of the ratio by the same non-zero number x. Then I'm getting 3x as the length of PR. But already we know the length of OP, that is 10 over here. So we can plug in 10 for this 2x. Then we get 2x equals to 10. If I divide both sides of this equation by 2, then I'm getting x equals to 5. Okay, now I can plug in x equals to 5 over here to get the length of PR. When I plug in x equals to 5 over here, then I'm getting 3 times 5, which is equal to 15. Okay, now I got the length of PR, that is 15. Already we have the length of OP, that is 10 over here. Now we got the length of PR, which is 15. So the radius of the bigger circle is 10 positive 15, which is 25. Now I got the radius of the bigger circle 25. Okay, now let me start finding the length of the minor arc RS according to the question. Okay, let me write the stuff over here. Length of arc RS, minor arc. Let me write it. Okay, already I know the formula to get the arc length when the central angle of the arc is given in terms of radians. That is R times theta. So here this R represents the radius of the circle on which we have the arc. Actually, we have this arc, minor arc RS on the bigger circle. So we have to use the radius of the bigger circle. Already we got the radius of the bigger circle 25. So we can plug in 25 for this R, and this theta represents the central angle of the arc. Already we know that the central angle of the arc is 2 pi over 5. We can plug in 2 pi over 5 for theta. So here 5 goes into 5 one times, 5 goes into 25 5 times. When I multiply this 5 and 2 pi, I am getting 10 pi. So the length of the minor arc RS is 10 pi. We find 10 pi and in answer choice B. The correct answer choice for this question is B.